Welcome back. Now let us explore little bit of color spaces, and I hope you recollect this part. We had discussed the color how the color image is different from the gray and black and white. What is the RGB all about? Then we had also discussed the HSB and CMYK and medical things we are not taking in this course. Okay, so what I'm trying to say in this video, that working with RGB is little bit different from the gray, but working with other color space from RGB is also little bit different. And as a human being or as a programmer, as an engineer, we have been more comfortable with RGB, and similarly lot of the library they have been built to work with RGB fairly in easy way. So let us show you one way, and HSB is this one. This is HSV. This one I will show you with OpenCV. Probably in future classes I will show you, because this is one of the very important one as well, that how to work with that. First of all, let us import that fill the color. That's all. So in 514 we are importing, and 51C, let's see the colorful image. So this is the colorful image. Yeah, so this is what it colorful image. This is in RGB. Okay, if you want to convert to some other example, I have taken the lab. So actually it is CIELAB. So where L means luminance and AB is the two-dimensional data, and detail about this color space is already over here. Okay, so how can we go ahead and do that? From the color, this function, we can convert any to anything. So from RGB to lab. So this is the lab image. We have done the conversion, and if you see the shape of it does not change. If you see, shape of it does not change. Internally it has some different way, but it does not change. Okay, let us. But can you really, one thing, this 3 is the RGB, and here this 3 is a L, A, B. So if you want to see some, I will say first 2 row or so, or so part of the, let me show you there is some changes has happened, so that you believe that yes, this has been what I'm trying to see. For the small part, I'm trying to show you the very first array of this is the color image. Similarly for the lab image we can see. So I'm running it 524. See, so this is the actual image that is in RGB format that has been converted to this 3 number. So this 3, why did not change over here? This 3 and this 3 are different. This for the color image, this 3 represents RGB, and for the lab image this represents L, A, B. So this is the value of L. I will explain what is the range of L in a few minutes. And this is A and this is B. Okay, this is a B. Now you cannot display the lab image, because as soon as you start displaying the lab image, your as soon as you display the lab image, lab will all the library like PLT, it knows how to interpret the RGB but not your lab image. So we have to convert it back to the RGB to display. But you should know the sum of the how to go ahead and do it. So I was talking about L, which you see over here. L range is 0 to 100, age minus 120 to 127 plus 127. Let me write it proper so that there is no confusion over here. And B is also minus 122 plus 127. Okay, so this is what it ranges. So you have to do some kind of offsetting over here, the way it has been done. and normalize it. So this is the lab image. If I try to do it over here, see, I right now have not normalized. So 532, if I run it, it will give the error. So it will give the error. But when I add it, the offset plus normalize 529, then it become in form of RGB. And now if I 532, if I run it, it will show me the image. Okay. But if you see, it has not been done properly, because there could be the few things over here, few things which we have not converted over here properly. So what I'm trying to convey over here, that if you, because this may not be the right way, and you may ask what is the right way. From the lab image, again you use this way, this way. Okay, you saw this image when we displayed this part after adding the offset and then normalizing, it did not come good, because this is not the right way to convert from lab to RGB. This is what I've just tried to show you, that this is the internally does in this way. And then what is the right way to go ahead and do it? This is the lab image. Whenever here we have modified, so let me take it again. So here let me read the color image again, so that at least you have here. Okay, so I'm reconverting it from the color image to lab image. Okay, I'm reconverting it, and then I'll show you what is the right way. So now the lab image is the pure lab image right now. This time I'm not converting lab image to RGB like this. Okay, so lab image, if you try to plot, definitely it will be that. So what you can do, you can have something like this. You can convert lab image to RGB image like this. So this is our lab image. We are using the function that lab to RGB. So if I run this 533, it will give me the proper way. Okay, this is the proper. So this is the right way to do it. This is the right way to do it, and not the other way around. Say this one I just tried to show you the example way. Similarly, if you convert to anything else, like we'll also discuss that about HSV, and so you have to convert back in a proper fashion. Okay, now let us go and see the these images in all by one. So this was the lab image with 3 channel L, A and B. So let us see what does it show. 536. I'm running the 536, and this is the things. Okay, and how to interpret these things, I'll request you will understand that as soon as you get into detail of lab from this site. I have given over a Wikipedia. This is given very good detail. Somehow it is not that lab is useful. I've just tried to show you that in some cases you have to convert to other format, and in future class I will explain that why you have to convert to other format. In 537 again we are looking at the this 3 part which we had already seen, that red, green, blue part, each one, each layer. So that's all. So the main learning from this part was that in some situation you have to convert to other color space. Try to use the library like this in anything, going backward from one to another color space and so on. In the other color space also you can manipulate and change the data like this. This way, if you see each by each, it may happen that few may have the different dimension altogether. Okay, so you can change it the way you have done the changes for this RGB. Okay, that's all the learning from this one. Thanks a lot for watching it. See you in the next one.